Okay, next one. Two cars traveling the same direction in adjacent lanes on a flat straight section of road. And so they've got the positions shown here, so they're 22.5 meters apart. And we have got one car traveling at 38 kilometers an hour, another traveling at 57 kilometers per hour. One is accelerating, one is decelerating. So let's have a go at that. What I might do, so we've got to find the time and position relative to the car A, which car A will overtake car B. Cool. So what we might do is just add the accelerations onto this graph. Just undo that. I don't know what I'm doing here. We'll do them in blue. And so what we've got is this car has car A has an acceleration of 0.6 meters per second squared. And so it is going like, so it's got that velocity, but it's also speeding up. So its velocity will be increasing. So the acceleration is in the same direction. And so its acceleration is 0.6, what was it, meters per second squared. So just looking at the fact we've got different units there. So we're going to have to deal with that. And then this one is also, it's not accelerating, this one's decelerating. So you represent that as an acceleration in the opposite direction from what it's going. And it's decelerating at 0.4 meters per second squared, 0.4 meters per second squared. Now we've got everything on one drawing. The first thing, so this is probably going to call that V0 A. This one will be V0 B. This will be acceleration A, acceleration B. We don't need to put the naught in because it's constant. It's not just the initial acceleration, it's the acceleration at any time during the stage we're thinking about. That sounds all good. So let's just start sorting some stuff out here. We've got different units at the moment. We don't want that. We've got meters, meters per second squared, and kilometers per hour. So let's go with meters in seconds. So we want to change that 38 kilometers per hour to meters per second. So the velocity or the initial velocity, so V0 A, is equal to 38 kilometers per hour, which is equal to 38,000 meters per hour. And we want to get meters per second, so we're going to have to divide by 3,600. So it's going to be 38,000. We could do it the long way. So well, let's just do that. So 38,000 meters per hour times. So the hours is on the bottom, so we're going to have to put that on the top. And 1 hour is equal to 3,600 seconds. Those hours are going to cancel out. So it's 38,000 divided by 600 meters per second. So 38,000 divided by 3,600 meters per second, which is equal to 38,000 divided by 3,600 is equal to 10.56 meters per second. Seems reasonable. So V0 of car B, so the initial velocity of car B is equal to 57 kilometers per hour. Then we'll do the same thing as above. So we're going to times by 1,000 divided by 3,600. So 57 times 1,000 divided by 3,600 is going to give us 15.83 meters per second. Then what? Well, let's take this initial position. So we'll take zero displacement as being the initial position of car A. So let's just take that. Yep, that's what it's asked us in the question as well, just checking back to the question. And so let's just draw that on. And so positive's this way, and this is our displacement, and this is zero displacement at this point. So therefore, we're going to have an equation of motion for each of those cars. So let's do, we'll call it the, what are we looking for? The time and position that car A will overtake car B. Yeah, okay. So let's just work through this. So the position of car A at any given time is going to be equal to initial position of car A plus initial velocity of car A times time plus a half times the acceleration of car A times t squared. We'll figure out what that all is. So S naught is just 0 because we're taking the initial position of car A as 0. Then we've got V naught A is equal to 10.56 times t plus half times 0.6 meters per second squared is the acceleration of car A times t squared. So we have got 10.56 t plus 0.3 t squared is equal to SA. I'll just leave out that t now, position t, we'll just call it SA. Sorry, position t, a time t. Okay, so, or should I? Yeah, let's just keep it in t. Now let's think about car B. So the position of car B at time t is just going to be equal to the initial position of car B plus the initial velocity of car B times the time plus half times the acceleration of car B times time squared, which is equal to, so it's 22.5 meters. So units are consistent, so that's okay. Plus the velocity is initially positive, it's heading in the positive S direction, and it's 57 kilometers an hour, which is 15.83 meters per second, times time plus, now this time our acceleration is negative, it's decelerating, which is the same as a negative acceleration, and so we're going to be taking this away, so minus a half times 0.4 times t squared. So therefore the position of B at time t is equal to 22.5 plus 15.83 t minus 0.2 t squared. Now, at the point at which these two cars are overtaking, this distance is going to be the same for both cars. Therefore, at time cars overtake, we will have the position or the displacement of car A. The position of car A is the same as the displacement of car B relative to the starting point of car A. Therefore, we're going to have 10.56 t plus 0.3 t squared is going to be equal to 22.5 plus 15.83 t minus 0.2 t. 0.2 t squared. So now we'll start collecting things together and getting it in the form we want. So we want it in the form blah blah t squared plus blah blah t plus blah blah, where blah blah is a number. So let's take this here. So we'll bring everything across to this left hand side. So we're going to have 0.3 squared. So you can only ever add t squareds with t squareds and t's with t's and numbers with numbers. You can't add t's to t squares. So we're going to take this across. This is going to come to this side. It's going to be positive. And so we're going to end up with 0.5 t squared. Then we're going to have 10.56 t take away 15.83 t. So 10.56 take away 15.83 is going to be minus 5.27 t. Then we're going to have minus 22.5 is equal to 0. So I've taken everything across to this side and I've got it in the right form. So now we know A is equal to 0.5. I could take a negative of all that if I wanted. B is minus 5.27. And C is equal to 20. Oops, don't forget to take the negative with it. Minus 22.5. Then we can chuck that into the quadratic equation. Just do that. So we are going to get t is equal to negative b plus, or, oh well, what do we want to do first? We want to find that square root b squared minus 4ac first. So square root of b squared minus 4ac is equal to the square root of b squared is 5.27 squared. So the square of a negative is just a positive, so it's just the same as 5.27 squared. You could write it as negative 5.27 squared if you want, but it's the same answer because a negative times a negative is a positive. B squared minus 4ac. So then it's going to be, because we've got a negative c, so we're going to have two negatives in this. We've got this negative here and the negative for c. Those are going to cancel out, so we're going to get plus 4 times a 0.5 times c is 22.5. We've already sorted out the negative for that. And then we're just going to calculate what that equals, which turns out to be 8.531. So t is equal to negative b plus or minus square root. So this is, you have to learn this, b squared minus 4ac over 2a. And so that is going to, so we're going to get two answers. Maybe it might be the same, but well, no, they're not going to be the same. We're going to get two answers. So T1 is going to be 5.27, okay, plus 8.531 over 2 times negative, it's negative 22.5. Oh, 2a, sorry. So it's 2a, so it's going to be 2 times a is 0.5. The other answer is going to be T2. It's going to be 5.27 plus, nope, I already did that one. 5.27 minus 8.531 divided by 2 times 0.5. Figure those out. So we get 13.8 seconds and minus 3.261 seconds. And again, we can't go back in time with these problems. We're going forwards in time. So therefore, this is the answer we want here. And so car A will overtake car B after 13.80 seconds. When it asked for that, what else did it ask for? The time and position at which car A will overtake car B. I might just undo those underlines, and so we just need to substitute that back in. So let's sub T1 equals 13, actually it's not T1 really, that was my two answers and we'll come down to one answer. So sub T equals 13.8 seconds in. No, that's probably reasonable. I'm just thinking it seems like quite a long time. We're doing some quite interesting stuff now. I'll just leave it, it'll be right enough. We'll check it in a minute anyway. So sub it in, so let's substitute that into one of these equations. Let's call this 1, 2. n1. So that means that S, the position of car A at that time, well, we know the time, it's 13.8 seconds. So 13.8 is equal to 10.56 t plus 0.3 t squared, which is equal to 10.56 times 13.8 plus 0.3 times 13.8 squared, which is equal to 202 meters, 202.9 meters actually. And that's relative to A, so we're taking all our displacements relative to the starting position of A. So car A is going to have travelled 202.9 meters. Let me just double check again exactly what it was asking. So let's just check that before we finalize the answer. Check. And we're going to check it by substituting t equals 13.8 seconds in the other equation. So it's in equation 2, which is this one over here. Rather than write that out again, let me grab it. So therefore, the position of car B at 13.8 seconds is going to be 22.5 plus 15.83 times 13.8 minus 0.2 times 13.8 squared, which is equal to 202.9. Woohoo! So car A will overtake car B after 13.8 seconds. Let's just move this down here so we're not getting confused. And what we could do is just turn all this grey, since it was all the check. And we'll just add to this sentence. So car A will overtake seconds at position 202, let's say 203 meters, 3 significant figures, at 203 meters from starting position of A. Done. But the question also wanted to know the speed of the two cars at that point. So, the speed of the car at that time. So then we're going to have to think, right, now what equation are we going to use for that? So this is part B. And we want to know speed of cars when A overtakes B. So what equations have we got here? So let's go through them until we find the right answer. So we know the acceleration at time t is just the acceleration, which is constant. That's the whole point, and this has to be constant acceleration. What else do we know? We know that the velocity at time t is equal to the initial velocity plus the acceleration times t. So the initial acceleration times t, and by George, that's the one we want, because we know the time at which this happens, 13.8 seconds. We know the initial velocity of each car, and so therefore can figure out the velocity when they are overtaking. And so that's the one we want. Don't need to try and remember what all the other ones were. So therefore, for car A, speed when passing B, we've already said that above, So speed of cars, let me set it up here, so I'm not going to bother writing it again. So for car A, we are going to have, what are we going to have? V of A at 13.80, wasn't it? 13.8 seconds is equal to V naught, which was now there's a question about how we do this. Let's just stick with meters per second. So it was 10.56 meters per second for car A. So it equals 10.56 plus acceleration was 0.6 times 13.80 seconds, which is equal to 10.56 plus 0.6 times 13.8, which is equal to 18.84 meters per second. We'll just change that to kilometers per hour. So what we'll do is first we'll times with 3,600 to get meters per hour. So it's going to be 18.84 times 3,600, and then you're going to divide by 1,000 to change it to kilometers. So it's going to be 67.8 kilometers per hour. Might as well save some space and move that up here. And the velocity of car B, V of B at 13.80 seconds is just going to be equal to, what speed did it start at? So that was 10.56, 15.83 meters per second. 83 minus 0.4, I think, wasn't it? For deceleration, yep. It's going to be 0.4 times 13.8, which is equal to 15.83. 15.83 minus 0.4 times 13.8 is equal to 10.31 meters per second. Then we'll do the same thing to change that to kilometers per hour. So we're going to 10.31, we're going to times it by 3,600 to get meters per hour. Then we're going to divide it by 1,000 to get kilometers per hour. It's 37.1 kilometers per hour. So let's just write that out. When they pass, or when car A passes car B, but whatever, when they pass, car A will be travelling at 67.8 kilometers per hour, and car B at 37.1 kilometers per hour. Done. I hope. Should really find a way of checking those, but I'm kind of running out of time for today, so leave it at that. If you spot an error, let me know on the discussion board and I'll fix it.